Okay, I'm here with Professor Silvie Huijben, who is a researcher at Arizona State studying mosquitoes and malaria. And so actually, you can see up here, she has her little mascot up here. You can see it's like a stuffed, are those the parasites? Little parasites?
They are. So we have, this is dengue fever. We have a malaria parasite.
Oh, man.
Now, so, yeah.
It's like a whole breakfast buffet of
Exactly.
parasites. Yeah. So I guess the malaria, the mosquito carries many parasites. Is that right?
Yeah. So mosquitoes can transmit lots of different. Am I looking at you?
Yeah, it's fine. Yeah, yeah, it's fine. Yeah.
So mosquitoes can transmit lots of different parasites and viruses. So malaria is the most well known. I think killing about 700,000 people every year.
Wow.
600,000 every year. So that's a big one. But we have dengue, which infects a lot of people. Its mortality rate is much lower though.
Mm.
Here in the U.S., actually here in Arizona, we have West Nile virus, which 2021 was a big outbreak year, and they had about 100 people that died here.
No way, it actually died.
Yeah.
In like Arizona?
In Arizona, Maricopa County.
Wow,
yeah,
I didn't realize
exactly.
it was that high of
and that was
mortality rate.
It was a big peak that particular year.
And how many people are infected by it? Do they even know?
Top of my head, I think it was like 3,000, something like that.
And then 100
And I think that's the tip of the iceberg. Like an average young person like us wouldn't, we probably wouldn't be symptomatic. So it's mostly like the elderly that are like at most risk of like big complications.
And then what other things can the mosquitoes can also spread other disorders? Did you just mention Zika?
Yeah, so Zika, dengue, chikungunya, malaria. There's some lesser well known. There's like elephantiasis.
Oh, really?
Which is a worm.
Really? And that causes like the swelling?
Yeah, exactly.
Oh, okay.
Swelling, there's river blindness. And then our furry friends get heartworm in dogs.
Oh, that's spread by mosquitoes also?
Yeah,
I never knew that. Oh, wow.
So yeah, they're these tiny little critters, but they really, they have a really big impact. So mosquitoes are seen as the world's most deadliest animal.
So deadlier than the great white shark?
Yes.
The tiger?
Yep.
Yes?
Yep. It's deadlier. Do you know what the number 2 is?
Let me think about this. The number 2, Chuck Norris? No, he was like a TV martial arts star.
Well, you're close though, because he's part of the species. It's humans. Humans are number 2.
So we're number 2 after we kill, but mosquitoes are number 1.
Mosquitoes are number 1.
Wow. And who, as far as like people that are dying, you said 700,000. Is that young, old, like?
So for malaria, it is mostly 75% is children under the age of 5.
Okay, and
so really the young.
The young are very vulnerable.
And for malaria, it's also pregnant women. So pregnant women are like immunologically kind of interesting, and they lead to higher mortality rates too.
Oh, whoa. If a woman is pregnant, and she gets infected, can she spread it to her baby?
So she doesn't give malaria to her baby, but the malaria parasite is really good, and there's actually a pregnancy-specific parasite version.
No way.
And they sit in the placenta, and they thrive in the placenta. So that has a lot of impact on the baby.
Even indirectly.
Indirectly, right. So the baby gets a lot less nutrients, and they're often born premature or even just dead. So we have a lot of like fetal mortality.
Because the parasite is like stealing the essential nutrients.
Right, exactly.
Wow. Hi, that's crazy.
Yeah.
And yet the baby did not themselves have the malaria.
No, so the parasite doesn't cross, as far as I know at least. I don't think they're being born with malaria.
Wow. But still, it would be bad news. So my question for you is, and that's the subject of this video, is how is evolution relevant for you as and other malaria researchers? Like, why should we care about evolution?
Right. Well, we should always care about evolution.
Yeah.
There are so many things. I think that evolution explains malaria. And I'll start, I guess, in some general things and specifically what I do. But malaria has had a massive impact on humans in the past, and one of the most fascinating things is that we have sickle cell anemia that's very common in areas where historically there's been a lot of malaria. So in Africa there's these individuals that have a high frequency, a high likelihood of carrying 1 or 2 copies of this kind of diseased hemoglobin allele. And the interesting part of that story is if you have 2 copies, you get sickle cell anemia, and the chance without any like proper medical treatment that you die before the age of 2 is really high. So you think evolutionarily, like there should have been a lot of selection against.
So they should have removed that. Nobody should. It sounds really harmful. It should have been removed by natural selection, right?
Exactly. But strangely, it's very high frequency. So I think it can be up to like 20% frequency of the allele in the population.
Which populations are you talking about?
West Africa.
West
mostly.
Africa, okay.
Yeah, it's throughout, but West Africa is like has the biggest bulk of this.
So why in the world would so many people carry this apparently like harmful allele?
So, and this is where malaria comes in. It turns out if you have 1 copy, so you're heterozygous, so you get a healthy allele from, let's say, mom, and you get a diseased allele from dad, or vice versa. So you're heterozygous, you have 1 copy. Now you're actually protected against malaria.
Whoa.
So you're actually more likely to survive your childhood when you're exposed to malaria than if you're not.
Whoa.
Now this is in areas where even today, the likelihood of getting a infectious bite from a mosquito might be every single night. You might be exposed to an infectious bite.
So malaria, that's the real challenge, pretty much.
Right.
You know, like for humans that
Exactly.
have lived in that area. And so for if you are a carrier, it's like a lifesaver.
It is, right, exactly. But the weird thing is, so now you've survived your childhood. You're ready to have your own children. You're carrying this disease, and there's a good likelihood that your partner, or you don't carry this disease, you carry this 1 allele that actually was benefit.
Yeah.
Your partner might also be heterozygous. They also survived their childhood. Now, this is just Mendelian genetics, 25% of your children might get both your copies of this diseased allele and actually wouldn't survive their childhood because they have both copies.
Whoa.
Now, half of them would be protected against malaria. So this is the part that, to me, as an evolutionary biologist, is just fascinating, that an allele that can lead to high levels of mortality, right, like these deleterious mutations that shouldn't really be in the population, can be selected because they give an advantage. And that just goes to show you how big malaria really must have been.
That's the monster.
Yeah.
The malaria is like, that's the monster in the room. So if you and your partner are both carriers, you have a survival advantage, and you're living in a malaria zone, half of your children would also be carriers like you.
Right.
But I know we should sketch this out. 1/4 would have both.
Well, I'll sketch it out.
Yeah. What would that be? Yeah. So if we did the Mendelian genetics, because that's one of the concepts that we talk about.
All right. Yeah. Great.
In this course.
This is like the best example because it's malaria. All right. So HB. Call the good one A, and then we have H, B, and we'll call this one S. So this is, let's say, healthy, and this one is the diseased one. Okay, so this is mom, and then we have dad here. I don't know if you can see
I'm zooming it out, yeah.
All right, so HB stands for hemoglobin. So A would be the healthy one, and then S would be the diseased one. All right, so mom and dad each give their copies, right? Like one of their copies to their offspring. So if mom gives the A and dad gives the A, now this one would be both healthy copies. So in an area where malaria, this is where you're like...
That could be a death sentence.
It could be, right? You're just like, you've got healthy alleles, but you're also...
Normal hemoglobin.
Yeah, exactly. So normal hemoglobin, and you're normally susceptible to malaria.
Yeah.
Now, if you get the disease, quote-unquote, copy from mom and the healthy one from dad, you're heterozygous. So in this case, what am I going to put that? Let's make that a smiley face, right? So you're protected. And that's the same here, right? So you're heterozygous. So again. you know, you're protected. But then these ones, so now you get both your bad copies, and this is the certain death sentence, at least.
Well, I mean, some people do survive that, right? But it's painful.
Well,
it can be very painful, right?
And that's just like
have other health consequences.
And that's in a current medical environment.
I see.
You can survive, but and what we need to think about that this all evolved thousands of years ago, right? When there was not the medical.
I see.
The
So back in the day,
that we have, right? Exactly. Then. You know, this would have been for certain a death sentence, and you wouldn't survive past the age of 2.
Yeah.
This would have been a benefit. Of course, here nowadays, for even, you know, being like normal susceptible, you can still survive, right? Nowadays we have treatments, so it's more about do you have access to treatment?
So this is kind of back in historical context, yeah. I mean, there's a lot of people in America that actually are that are carriers or may come up with it, because those of us who have like African ancestors or Mediterranean ancestors from the Mediterranean, we may not even know that we're possibly carriers for this, or you know, it's interesting.
Right, exactly.
But yeah, let me ask you, how else is evolution relevant in malaria?
Right. Okay. Yeah. So this. Now I'll dive just in what I do, I guess. So I'm really interested in the evolution of drug resistance in malaria parasites, but also the evolution of insecticide resistance in mosquitoes.
Oh wait, so not just one, not the double, like there's evolution in both contexts.
Right, exactly. So, and actually to take a step back, really me as an evolutionary biologist, I'm interested in how do organisms evolve resistance against the interventions that we're throwing it out there. So it's not just anti-malarial drugs or insecticides for mosquitoes, but it can also be antibiotics for bacteria or antifungals for fungi, or even anti-cancer drugs for cancerous cells.
This is so great. I'll pay you later for making all these great. I'll give you the cash later. Thank you for making this great point. Okay, yeah.
So. But you know, as a researcher, we need to focus on some things. We can't do everything. I try to. Didn't work out. So I focus now on malaria parasites and the evolution of drug resistance in malaria parasites and insecticide resistance in mosquitoes.
I see. So the mosquitoes themselves, like you would try to kill the mosquitoes with insecticides.
Right.
But then they can evolve resistance to the insecticides.
Exactly.
Okay.
Yeah.
But then on top of it, then you could also try to kill the parasite, like that's in the blood.
Right.
But that also can evolve. It just seems like damned if you do, damned if you don't kind of situation, like where it's like you're fighting evolution on several fronts.
Right. Exactly. And the reason why I'm really interested in both is. It seems like such an easy problem, right? Like, and you'll probably all get this in your intro bio class now. You talk about like evolution, maybe you've heard already about it in high school, that antibiotic resistance is the sort of like the key example of natural selection, right? That's natural selection. So why would anyone need to study this? Like we already know how it works, right? You have some organisms, some of them are resistant, you throw some drugs at it or some insecticides. The ones that have the mutation survive, and the ones that don't are gonna die. And so obviously the ones that survive are then able to pass on their genes to the next generation. So it seems like such an obvious example.
Right.
The problem is, what do we do about it?
Yeah, and there's like, it seems like we understand that it's a case of natural selection.
Right.
But understanding that, how do you fix it? Like, it seems like a challenge.
Can you fight evolution? Can you fight, can you reverse evolution, or can you use it to our own advantage? And so one of the really interesting things, I think, now in evolutionary biology is, can we manipulate the situation in such a way that maybe we even force these organisms down an evolutionary trajectory that benefits us and doesn't benefit them? Because the good thing about evolution is it doesn't have a foresight. It doesn't know where it's going to go. It only knows at this generation who survives, who dies, who's passing on their genes.
Interesting. I wonder, could we, you said we might be able to go to the lab, could we see some mosquitoes and some of the parasites?
Yeah, let's
do it.
Let's
head to the lab. Okay, awesome. Okay, so So Professor Huijben, we're getting ready to go in the lab, but this is like, you have to have high security, right? Because
Right, yeah, so not everybody's allowed. This is a restricted area, so you need to have a special pass and a pin code to be able to get in.
Okay, all right, let's go
I'm
in.
allowed to take you
Okay,
in.
let's go in. Okay, all right, this is exciting. Okay. Awesome.
All right, so this is Don Moore. He's one of my PhD students. He's actually studying this insecticide resistance that we were talking about.
Oh, really? No way. Okay, Don, would you mind? Could we see some mosquitoes or some of the parasites?
Absolutely.
Oh, let's go back there. Yeah.
So we have 3 full chambers full of mosquitoes, but I primarily work in this chamber right here.
Oh wow! Look at this. Cool.
So, as you can see, we have a bunch of different racks full of mosquito larval trays. If you want to take a look, you can actually zoom in on this one.
Oh yeah. Let's see
So
here.
we have a bunch of mosquito larvae in this tray right now. So that's like the second stage that comes out of the egg.
Whoa!
And we
Yeah.
have a couple other mosquitoes that are at the pupal stage right now, and that stage gives rise to the adult mosquito that we normally know about flying around in the field that bites us.
So those little guys, those are mosquitoes right there. Mosquito
Yes.
larvae.
So
Whoa.
it's a mixture of mosquito larvae and mosquito pupae.
Uh-huh.
Yep.
They look so alien.
Yeah, for sure. So in this room, we have 2 different species of mosquitoes. One called Culex quinquefasciatus and one called Culex tarsalis. Both of them are vectors or transmitters of West Nile virus. Currently, we don't have any infected mosquitoes in this lab right now, but all of these we rear for different insecticide resistance experiments and for our general mosquito colony.
I see. So so you deal with the challenge of the fact that mosquitoes are evolving resistance to the strongest insecticides that we have.
Yes.
Yeah. Wow, that's cool. And so these are whole nets full of live mosquitoes up here.
Yeah, so there's like between 500 and 1,500 mosquitoes in these smaller cages, and this one has about 3,000 in
Wow.
And we hold those mosquitoes for like 1 to 2 months, and we feed them blood in order to give rise to the next generation of mosquitoes and keep that
Wow.
keep that cycle going for our research.
Where do you get the blood? Is that what you have the unpaid undergraduate interns for?
No, fortunately we do not force undergrads to give their
That would
blood.
be slightly unethical, right, Professor? Yeah.
Yeah, we source our blood from blood banks.
Blood, really?
Yeah,
Oh,
and,
whoa.
with certain qualifications that allow mosquitoes to feed
Oh, whoa.
certain blood types, they'll feed on better and produce more eggs.
So they really do prefer certain blood types.
Well, at least we know that they produce eggs better with certain blood types.
Oh.
Whether or not they'll feed on people with different blood types, that I'm not too sure about. I think it's more about they'll feed based on the differences in your skin microbiota.
Oh, yeah.
Smells that you're emitting.
Yeah, I got this one kid in my family, and like the mosquitoes just go to town on her. Like I just feel like she would die for sure in a malaria zone.
Yeah.
And the rest of us are unbitten, and she's covered in bites. I don't know something is going on. Yeah.
Yeah, so it's most likely with your skin. So we have a lot of like bacteria living on our skin, and they all emit certain odors.
Oh.
So some people are just lucky enough to smell really nicely to a mosquito. And
Yeah, so lucky, I guess.
lucky or unlucky?
Wow, this is really interesting. And do you have to like account for every single mosquito in here? Is that like?
So if we do by chance have an escapee, which can happen just doing general mosquito rearing, we try to kill it. They're not infected.
They're not infected. Okay.
Yeah, nothing in our lab at all is infected right now.
I see. So you wouldn't be harmed if the mosquito bit you.
No.
Oh, I see. Okay. Wow, fascinating. Well, thank you so much, Don. This
Yeah,
is really
of course.
interesting. Who's this colleague?
So this is our new undergrad, Sky. She's I'm training her on how to perform the mosquito rearing task, taking her out into the field to collect mosquitoes and stuff like that.
Awesome. Well, thank you so much, Don and Sky. Do you have any thoughts on working with mosquitoes? Anything?
It's been interesting and fun to learn about so far. I've been enjoying it.
That's great. I'm so glad to hear. You guys are making a difference. Like, I feel like my research just seems so pointless compared to what you guys are doing. Like, your research really has the capacity, has the hope of helping humanity. And me with my hissing cockroaches or ants. It seems so silly by contrast, But thank you for
all important.
That's true.
You
It is
know,
all.
science is
It's the
important.
quest for knowledge. That's
Yes.
That's what I tell myself. Yes.
Yeah.
But the funding agencies don't seem to believe me. But but yes, thank you so much for the tour.
Of course.
Yeah.
Okay. Wow, that was so interesting. Well, Professor Huijben, I just want to thank you. That was so
Yeah.
interesting. Very, very
My
interesting.
pleasure.
And
Yeah.
what an eye opener. And good luck in your quest fighting humanity's ancient enemy, the mosquito. And
Thank you very much, and I hope all your students are going to be inspired, and they all want to do evolutionary biology.
Yeah, good. That's a good plug. Yeah. All right. Thank you, Professor Huijben.
Yeah, you're welcome.